Part 3. Standard deviation. Standard deviation is a measure of how close or how far away the data values are from the mean or the average. If the standard deviation is small, then it indicates that most of the data values are close to the mean. The data is more consistent. More consistent means lower standard deviation. If the standard deviation is large, then it indicates that most of the data values are scattered farther from the mean. The symbol for standard deviation is sigma, and of course that's the Greek letter sigma. Example 1. The coach of a varsity girls basketball team keeps stats on all of the players. Near the end of one game, the score is tied, and the best starting guard has fouled out. The coach needs to make a substitution, so he examines the field goal stats for the 5 guards on the bench over the last 10 games, shown in the table below. So, of course, each of these represents a game. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and game 10. Okay, so remember from our last little bit, the range, of course, is the largest number take away the smallest number. The mean, of course, you would find by adding all of the numbers up and dividing by 10, because there's 10 sets of data. And the standard deviation is a value that can be calculated by hand, but I'm never going to ask you to do that. I'm going to have you take a look at the videos on the website that have you determine the mean and standard deviation. It's called 1var stats. So make sure you take a look at that video before you go any further. Okay, so the range then is the biggest number take away the smallest. In this set of data for Anna, the largest number is 45 and the smallest number is 27. So 45 take away 27 is 18. When you put your data into your graphing calculator, you'll find that the mean is 36.7. Okay? And the standard deviation, we usually round to 2 decimal places, so 5.88. Okay? Good. Do the exact same thing with Patrice. Okay? And so you'll find that her largest number is 39. And her smallest number is 34. So 39 take away 34 is 5. And when you type this into your calculator, if you're having any trouble, remember to go ask your teacher. But if you follow the video, it should give you a mean of 36.4 and 1.50 for standard deviation. Morgan has the highest number of 48 and the lowest number of 19. So again, when I subtract those two things, I get a range of 29. And on my calculator, I get a mean of 35.8 and a standard deviation of 9.02. Remember, the bigger the standard deviation, the less consistent this person is. Alright, moving on to Paige. Paige's highest score is 35 and lowest is 33. Notice there's a number of 35s and 33s. So 35 take away 33 is 2. And the mean is 33.9. Standard deviation 0.83. Ooh, that's pretty low. Last we have Star. Star has a high score or high percentage of 41 and a low of 29. So when we subtract those two things, we get 12 for a mean of 36.3 and a standard deviation of 3.35. Okay, so we just did what Part A asked us to do. Determine the range, the mean, and the standard deviation for each player and record the results in the chart. Alright. Part B. Who is the most consistent shooter? Remember, most consistent equals lowest standard deviation. So the lowest standard deviation belongs to Paige. Okay, would you use her as the substitute? Well, although Paige is extremely consistent, she is actually the lowest scoring of the remaining players on the bench, so I would probably not use Paige as my substitute. No, lowest scorer. Okay. Part C, which player has the greatest percent range? Which player has the least percent range? How do their standard deviations compare? Okay, so the greatest range belongs to Morgan. Okay, and the smallest range belongs to Paige. Now, if we take a look at their standard deviations, Morgan's standard deviation is a whopping 9.2, where Paige is a lovely 0.83. So, guess what? The greatest range also produced the greatest standard deviation, and the smallest range also produced the smallest standard deviation. If you were a coach, which player would you substitute into the game? Explain why. Okay, if I were this coach, taking a look, I would probably put in Patrice. Here's why. Patrice had the second highest points percentage, and she also has the second lowest standard deviation. So what does that mean? That means that she consistently gets fairly high scores. So she's my choice for who I'd substitute in. Okay, now's an opportunity for you folks to try on your own. Again, you're more than welcome to watch the video till the end and then go back and try this on your own, or you can fill in as I go. Or you can shut the video off, try it, turn the video back on, see how you did. Either way, it's all good. Alright, example number 1. Angele conducted a survey to determine the number of hours per week that grade 11 males in her school played video games. She determined the mean was 12.84 hours with a standard deviation of 2.16 hours. Janessa conducted a similar survey, but she used grade 11 females instead of males. She organized her results in this frequency table. Okay, so, what is different about this table compared to the one in the previous example? So if we take a look at this example over here, notice I have each of my players listed in all of their data. Those are called raw scores. Over here, however, you can see that the data has been organized into a frequency table. Okay, so example 1 had raw scores for each person. This question uses a frequency table. Okay, summarize the results. Well, males, we already were given the information. So the average for males was 12.84 hours, and the standard deviation at 2.16. For females, we're going to have to find it. Now, when they give you data in a frequency table, notice that there's a range of hours. So in order for us to actually find the mean, we have to use the midpoint of that range. So, hours 3 to 5, halfway in between, or in the middle of that is 4. 5 to 7 is 6. 7 to 9 is 8. You see a pattern here. 9 to 11 is 10, 12, and 14. Again, I would be using my graphing calculator, and I would be putting my midpoint in L1 or in my first list, and my frequency in L2 or my second list, depending on what kind of graphing calculator I have. Good. Again, you may need to rewatch the video on how to type this onto your particular calculator and do, of course, your one variable statistics. Remember that one variable stats here, you're going to have to go L1, comma L2 because you have 2 columns of data that you need to put in the information for. Okay? Good. Once you type this in, you will find the mean to be 8.94 for the girls with a standard deviation of 2.78. Okay, So, what are some conclusions we can make about the male and female players? Well, first of all, males played video games for much longer, approximately 4 hours, than girls did. Okay, and the data was more consistent. So what that means is that was more consistently played. I guess I should say males. Males played more consistently than females. Okay, good. Alrighty. That looks like that's it for those examples. So if you think you're doing all right, please try questions on page 261, numbers 2, 4, 6, 9, and 10. Show your teacher when you have completed this assessment.